Okay. Yesterday we were looking at descriptive. I'm sure you are able to see something on the screen. Before we proceed, I wanted to make a correction on the computation of mean of grouped data. In the initial formula that I gave you yesterday, if you go back to what you wrote, we were dividing with the number of the classes, then subtract by 1, which is not correct. What we should have is the total number of the frequency. In other texts, you'll find that they'll put n like in ungrouped data, but that n represents the sum of the frequency. In other books, they'll put summation f. So it should be summation xf divided by summation f. So summation x, which is the midpoint, multiplied by the frequency, divided by summation of the frequency. That's the formula for mean for grouped data. We were able to calculate the variance, we worked on the mode, and we were supposed to start the quartiles. Now, quartiles, the best way to approach a quartile is to split a set of ordered data into 4 parts. So what you do is, when you are given data or the measurements in a set of data, you first arrange them as we discussed, either in ascending order or in descending order. Once that data is arranged in that order, you are going to split that data into 4 parts. So when you split that data into 4 parts, it will simply mean, depending on how many elements or how many measurements will be per part, that will be the way you are going to identify your quartiles. So for the first quartile, it will be the third observation. So you break your measurements into 4 parts. In the first part, the third observation in the first part, that is your first quartile. And the third observation from the last measurement, that will be your third quartile. That will be your quartile, your third quartile. So if you look at these illustrations here, we have arranged our data in order, starting from 210, 220. Hello?
Hello, yes. I'm using the phone now.
Okay, good. I'm able to hear you. Okay, that's interesting. Okay, now.
Let me just close the laptop.
Okay.
Okay, it's fine now. We can continue.
Thank you very much. So we have divided our measurements or this set of data into 4 parts. So the first part of your measurements that you have divided, you look for the third observation from the beginning. So the measurement or the element on the third position becomes your first quartile. And if you go to the last part of your measurement, you discover that there are elements or measurements in that fourth part of the division. Again, you start counting from the last measurement, meaning from your right coming to your left in the last part of your division. The third from the last becomes your third quartile. So let's quickly look at a practical example that will help us understand the computation of first quartile, median, and the third quartile. If you look at...
So, just a second.
Yes.
Hello?
Yes.
Is it possible to record the session?
Actually, I'm recording it. If you want, I can send it. There's a recording button there. If you want, you can record yourself. It's fine.
Okay, I've seen it. I'm recording. Thank you.
Okay, you're welcome. So we can proceed. Okay, yes. So there we have got computer cells. Now, we had 12 salesmen. So the number of our measurement is 12, and it is represented by N. So these measurements were listed haphazardly there. So according to what we have learned is, the first step is to arrange our measurements in ascending order or descending order. So we have arranged our data. If you look at the first order, the data looks like that. So when you arrange the data like that, you will find that if you count this, they are about 12. So let's start by computing our mean. We said, yes, we said mean for ungrouped data is the total sum of the measurements divided by the number of the measurements.
Yes.
Yes, so we are able to add these measurements here, and they gave us 76.
Yes.
So we divide by the number of measurements, which is 12. So 76 divided by 12 gives us 6.33. That is our mean of this sample. Then we can proceed to calculate our median. Now we said the median is the middle measurement in the data set. Now, in an event that your measurements are an even number, then we are going to get the two numbers that are at the center, add them together and divide by 2. So we have gotten 6 and 7. So that on your right, you have got 5 measurements, and on your left, you have got 5 measurements. So 6 and 7 are the measurements at the mid. So our median is between 6 and 7. So what is the number which is between 6 and 7? So we add 6 plus 7 and divide it by 2, and it gives us 6.5. That's how we
Yes.
calculate our median in ungrouped data.
Median.
Yes. So we move to the mode. We said once we arrange our measurements in order, we find the measurements that has got most appearance. That becomes our mode.
Yes.
So if we look at our measurements here, we have got the measurement 10, which is appearing twice. So that's what we pick as a mode. So we pick that one as our mode.
Hello?
That's how we calculate our mode. 10 is appearing twice. So it becomes our mode. Then we are also able to calculate the lower quartile or the first quartile and the third quartile. Now, as we mentioned, we said what you do is if you have got measurements which are an even number, hello? Hello? Can we proceed?
Hello?
Okay, yes, we can proceed. Your microphone is mute. Just unmute it. Okay, thank you. So, we are to calculate our lower quartile. So, what you do is,
Yes.
you are going to, so our 6 and 7 is our, that's where our median is. So if you want, you can put the brackets. Where you see 7 and 8, put the bracket to cover the upper part, and where there's 5 and 6, put the bracket to cover the lower part. Now, in your lower part, how many elements do you have? You have got 1, 2, 3, 4, 5. And on the upper part, you have got 5 elements. So what you do is, we are moving, we have got the number between 3 and 4 on the lower part. And on the upper part, we have got the number between 9 and 10. So if you are moving from the bottom, we have got 3 and 4. If you are moving on the other part, you have got 9 and 10. So your lower quartile is between 3 and 4, and your upper quartile is between 9 and 10.
Just on that one.
Yes.
Network is not stable. The network. Just on that one.
Yes. On this one.
Hello.
Yes, I'm hearing you.
Are you able to go back a bit? Yeah, on the last point.
Yes, about the lower quartile.
On the quartiles.
Yes.
The way we found the 3.5.
Okay. Let's move forward. Let me demonstrate on what is very clear now. Are you able to see the data that we are given there? We have got,
yes, I've seen it.
yes, 16 elements, okay?
Yes,
Yes, so I was saying you break your data into 4 parts.
yes,
Yes, so have you seen how we have broken our data into 4 parts using those red dots?
yes, 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 yes.
Yes. So I think this is the best way to handle quartile because that one was painted with those mid numbers. So you break your data into 4 parts. So the first part has got 4 elements. The second part, 4 elements. The
Okay.
third part, 4 elements. And the fourth part, 4 elements. So how do we find the mean? We add all these elements. They gives us 65.
Yes.
Divide by the total number of elements, which is 16.
Okay.
It gives us 4.06.
Yes.
So the mean is okay. Can we move to the median?
Median, yes.
Okay, if you look at the median, we are looking for the number which is at the center. Now, this is the 16 elements, which is an even number.
Yes.
So we are going to
Yes.
find, we will count 7 from the right hand side coming and 7 from the left hand side going to the right. We are going to have
Yes.
2 numbers at the center, which is 3 and 4.
Yes.
Yes. So you add 3 plus 4, divide by 2. It gives us 3 plus 4 is 7,
Okay.
divide by 2, it gives us 3.5.
3.5.
Yes, that's our median. Our mode, we are looking for the number that is appearing most. So we look at our data set, we find 2 is appearing most.
Yes.
Exactly. So we go to the quartiles. We want to find the lower quartile, the middle quartile, and the upper quartile. Now, when you are asked to calculate the middle quartile, what they are asking for is the median. So the middle quartile is the same as the median. So just give them the median.
Okay. Okay. Just on just okay.
Yes.
So we are saying mid quartile is the same as the median.
Exactly. Mid quartile is the same as the median. So you give them the median figure that you have calculated.
Okay. Okay.
So
okay.
let's calculate the lower quartile. Let's calculate the lower quartile and our upper quartile. Okay, so when you are calculating the upper quartile, or let's start with the lower quartile. The lower quartile is found in the lower part of your demarcation, in the first part. That's where the lower quartile is. The upper quartile, we look for the upper quartile in the fourth part of our division. That's where our upper quartile is. So we are looking for from the last number of the lower part. From the last number of the lower part, which is a 2 before the red mark. Are you there?
Yes, I'm here.
Okay, so the lower quartile is between the last number of the first division and the first number of the second division. That's where the lower quartile is. So the lower quartile is between these two here and these two here. Between, that's where the lower quartile is. So what do you do? Because here there is no number. So what you do is you add the last number from the first part and the first number from the second part. Add them and divide by 2. That's how you find the lower quartile. So
the lower quartile, that's the
lower quartile?
Okay, I'm here.
Yes. The lower quartile.
I was saying the lower quartile.
Yes.
That's the third quartile.
No. The lower quartile is different from the third quartile. The third quartile is the same as the upper quartile.
Okay. Okay.
Yes. So the lower quartile is the same as the first quartile. Then the middle quartile is the same as the median. The third quartile is the same as the upper quartile. So if you add the last number in the first part plus the first number in the second part, which is 2 plus 2, divide by 2. That is your first quartile. 2 plus 2, divide by 2. That is our first quartile. How do we find the middle quartile? We want to prove the fact that the middle quartile is the same as the median. So, for us to find the middle quartile, we pick the last number in the second part and the first number in the third part, add them together and divide by 2. What is our last number in the second division, in the second part? We have a 3.
It's 3.
Yes. Then what is our first number in the third part? We have a 4.
We have a 4.
Yes. So we add 3 plus 4 gives us 7. Divide by 2 gives us 3.5. That is our middle quartile, which is the same as our median.
Median.
Exactly. So the median is the same as the middle quartile. Okay. Are we able to calculate the third quartile?
So for the third quarter, we are looking for a mode.
In the third quartile? No, a mode is not the third quartile.
Yes.
A third quartile, we are looking at.
So the mean.
Yes.
Because the median is the middle quartile.
Yes. That's the only figure which is similar in this scenario, because middle quartile is at the center of the distribution and the median is at the center of the distribution, so it is the same.
Okay.
Yes. But for the third quartile is similar to 75th percent.
Okay. Yes.
Yes. But the middle quartile and the median, that is the 50th percent.
Yeah, I've seen.
Okay. So let's calculate our upper quartile. So we always look for our upper quartile between the third part of our division and the fourth part of our division. That's where we should find our upper quartile. So we pick the last number in the third part and the first number in the fourth part. Add them together and divide by 2. That is our upper quartile. So our last number in the third division is 5. And our first number in the fourth part is 6. So you add 5 plus 6, divide by 2, and it gives us 5.5 as our upper quartile.
Okay.
Yes. When you are dealing with quartiles, there was a tutorial note that I saw which were given to you by one of your lecturers. It's very complicated.
Yes. Okay.
Yeah, that one is very complicated. But I prefer maybe this one may be easy for you to understand. So when you are given the data set, divide it into 4 pieces. When you divide it into 4 pieces, the first quartile is the last number in the first part plus the first number in the second part, divide by 2. That is your first quartile. Your middle quartile is your last number in the second part plus your first number in your third part, divide by 2. The third quartile or upper quartile is the last number in the third division plus the first number in the fourth part, divide by 2. That is your upper quartile.
Okay.
Has it helped?
Yes.
Okay, thank you very much. You can practice the next exercise where we are given the data set, number of absences. In this question, our measurements is an odd number. It is 13. So how do we find the first quartile and the upper quartile in an odd number as our measurements? We have got 13 measurements. So they want us to compute the mean, the median, the mode, and the quartile. Now, step 1, arrange your data in order or ascending order. So we have arranged it. Yes, 0, 0, 0. We put them in order. Once you put them in order,
yes,
we start dividing. We are told to divide into 4 parts. Now,
yes,
what is happening here is, because this is an odd number, we are able to pick our median easily. We just push 6 measurements on our right and 6 measurements on our left. The number that is between, which remains at the center, is our median. So if you have seen there, we are pushing 6 elements on our left and 6 elements on our right. We are remaining with 2 at the center. So we pick it as our median.
yes,
Yes, so we go to the mean. We said add all the measurements in the data set and divide by the number of the measurements. So when we add these measurements, they are giving us 39. 39.
Yes.
Then how many are they? They are 13. Divide by 13.
13.
Yes. We are able to find 3.0. That is our median. That's our mean, I mean. So our mean is 3.
Yes.
Then let's find our mode. We said mode is the measurement or the element that appears most. We find that in our data set, we have got 3 zeros. So 0 becomes the mode.
Yes.
We must be careful to avoid the temptation of writing the number of appearance as the mode. Most of the times, the students are tempted to write that. Don't say mode is 3. No, mode is 0. 0 is appearing 3 times. So the element which is a mode is what we write as the mode. So the mode is 0, not the number it is appearing, no. Okay?
Yes.
Are we able to calculate the quartile, the first quartile? As we said, we have divided our data elements into 4 parts. We assume even the 2 there, which is marked red, is a division. That is the middle point, not so?
Yes.
Yes. So our first quartile is the last number in the first part, which is a 0. And the first number in the second part, which is a 1. So 0 plus 1 is 1. Divide by 2 is 0.5. So our lower quartile is 0.5.
So just on that one.
Yes.
Hello.
I'm hearing
So
you.
this data,
Yes.
when finding quartiles,
Yes.
we are supposed to divide it or to group them into groups of 4s or groups of these.
No, it's not about the number of items per group. It's about breaking it into 4 parts.
Into 4 parts, whatever the elements,
Whatever,
break them into 4 parts.
Exactly. Whatever the elements per part, what is important is divide it into 4 parts.
4 parts, okay.
Exactly. So for the first quartile, we picked the last number in the first part and the first number in the second part and divided it by 2. That's how we found the 0.5. Then for our upper quartile, the upper quartile, we are saying we go to the third part and pick the last number in the third part, which is a 4. Add it to the first number in the fourth part, which is a 5. 4 plus 5 is 9. Divide it by 2. It gives us 4.5. So our upper quartile is 4.5. Is that okay?
Yes. For the upper quartile or the third quartile,
Yes.
you said you pick the number in the third part.
The last
number in the third part.
Exactly.
In the third part.
Yes.
Which is a 4.
Exactly.
And then the other number came from.
We go to the fourth part and pick the first number.
First number, which is a 5.
Exactly. So we are picking the last number from the previous part and the first number from the preceding part. Then you divide by 2. Exactly. So you discover that if you are looking at other writers, the way they describe the first quartile and the upper quartile, like in your lecture notes that I saw, they were using, if they want to compute the lower quartile, they are saying the lower quartile is the number immediately above 25%. And the upper quartile is the number immediately below 75%. That's why you are finding that we are adding the last number of the first part plus the first number of the second part. Here between where the red mark is, that is where your lower quartile is. Immediately above 25%, which is the third observation. And here they are saying immediately below 75%, which is below the third observation from the last element, somewhere here. That's how other books have explained the upper and the lower quartile. But I have decided to explain it in this way. Are we able to proceed?
Okay, we are together.
Okay.
Yes, sir.
Yes. So if you look at the next exercise, I think you can try to practice. If there's any challenge, let me know, then we can talk about it, but it's equally the same. This data, the data elements are 16, which is similar to, it's an even number, the one that we started with. I want to look at I wanted to look at the range, okay? Interquartile range. How do we calculate the range? Are you able to see on the screen something?
Yes.
Okay, so
The range.
yes.
So,
the range is the difference between the largest value and the lowest value. That is the range. Okay? Hello?
yes, I'm here.
Okay, so the range.
I've seen the page.
Yes.
I made a hard copy.
Okay, so the range is the difference between the largest value and the smallest value. So when you are given a data set, all you need to do is find the highest figure, subtract the lowest figure. So like in this example, the highest figure was 30 and the lowest figure was 9. So our range is 30 minus 1, which is 29. Highest figure 30, lowest figure 1. 30 minus 1 gives us 29. So our range of this data set is 29. Let me talk about interquartile range as we are winding up. Interquartile range is the difference between the upper quartile and the lower quartile. So all you need to do is, what is your upper quartile minus your lower quartile? That's how we calculate the interquartile range. So whatever figure you find as your upper quartile, subtract the lower quartile, the difference will be our interquartile range. So if we look at our previous demonstration, yes, In the previous demonstration, we found the lower quartile was 0.5 and the upper quartile is 4.5. So our interquartile range, then will be 4.5 minus 0.5, which should give us 4. So our interquartile range is 4. Okay, so that's how we calculate interquartile range. Is that okay?
Yes, it's okay.
Thank you very much. If that is okay, you can try to practice. There are other questions that are there that could help to enhance your understanding, so that if there are any challenge, let me know as we begin our next session, we can try to go through together. In our next session, we start looking at...
Thank you, I'll do that.
Okay. So in our next session, we will try to look at what are called measures of dispersion or measures of variation. So we'll be looking at the standard deviation, the variance, and the coefficient of variation. That's what we are going to look at next time as we meet. I think for today, unless if there's anything that I can clarify, we can end here.
No, it's fine.
Okay, thank you very much. And when is our next? Yes.
Maybe in my I think my recording was not recording. If you can send me the audio, the recorded one, maybe it's will be much better.
Okay, no, I'll consider that one.
Okay, thank you.
Okay, thank you
Our
very
next one should be on Wednesday.
Our next class is on Wednesday. Okay, so we can start from there.
There's Wednesday. Yes, sir.
Okay, thank you very much.
Thank you, sir. Good night.
Same, thank you.